Okay, in the last class, I gave you this question where we had to find uncertainty and the quantity. We had to find Young's modulus with quantity and its uncertainty. Now, let's start. Now, first of all, step one, you calculate E. Calculate E. For that, we put all the normal values into the formula and calculate its value. 4 multiply by, instead of force, we put 12.5, multiply by L is 1.45. Be careful for the units. Okay, all of the units should be standard units. Divided by pi, because the calculator can put its value of pi, so we will leave it as pi, multiply by diameter. So diameter is given as 0.55 into 10 to the power 0.02 millimeter, but the formula can only have meter in it. So see, 0.55 instead of milli, we can write 10 to the power minus 3, and voila, we have this diameter in meter. So there is a square on the top for that. And then there is an x. X is 1.11, and this is also in millimeter. So it will be 1.11 into 10 to the power minus 3. So this is how we have to replicate this whole thing in one stroke in calculator. Just replicate this whole thing as you can see it over here in your calculator and tell me what answer you get. Anyone? Any one of you
Sir,
can tell me the answer. Anyone else can confirm it. Hello. Okay, listen. Um, can anyone confirm? Do you all get the same answer? Because I do not have a calculator right now nearby.
yes, sir. I got the same answer.
Okay. Now for the errors, uncertainty. We need uncertainty. So we can find uncertainty in two different ways. I am doing method one for uncertainty. Method one for uncertainty. Now listen. Because I know E is the product, F, L, D square, and X. These five things are the factors. I'm saying five. Most of you would say, no, sir, there are four, F, D, L, and X. I would say there is a D square. So it means there are two Ds. 4 and pi are not participating in the makings of uncertainty because they are constant numbers and they have no uncertainty. So they do not participate in the makings of uncertainty here. Now, what was the rule? If we go back, the rule was fractional uncertainty of the product has to be equal to sum of fractional uncertainty of the factors. So in this case, the factors are F, L, D, and X. So here we go. Unknown uncertainty of E divided by the quantity that we measured, 6.87 into 10 to the power 10 equals to fractional uncertainty of F. That will be 0.1 divided by 12.5. And in this case, you do not have to worry about converting units. Okay, they don't matter here. Plus L. 0.01 divided by 1.45 plus D 0.02 divided by 0.55, and I am multiplying this thing with 2. I hope you understand why. Because there is D squared, so it means there is another D. Either I can do plus 0.02 over 0.55, or I can multiply this one with 2. Plus uncertainty of X, which is 0.01 divided by 1.11. Here we go. Now, I will recommend that someone replicates this whole thing in your calculator in one go.
0.0966.
0.0966.
Yes.
And
It's a big number.
multiply it with 6.87 into 10 to the power 10.
Just a second.
6.87 into 10 to the power 10.
Four 4.56 into 10 to the power 20. 56 into 10 to the power 20.
No, it cannot be right. And secondly, I will recommend you that you take class in a quieter place. I think I have told you this before. I don't know how these things that I'm saying are making sense to you. Try to be in a quieter place so you can concentrate on what we are doing in the class. And you're not telling me the right power. Can anybody else tell me the power or
Sir, I'm getting a very big
what do
number.
we get if we...
So I also am getting
Yes,
very big.
you're supposed to
Can
get
I
a
tell
very
you?
big number.
Yes, sir.
Yes, please.
6638 6756 59. Yes, sir. Wait.
So you are like confused whether this number is okay or not. So I can say it can be 6.64 into 10 to the power 9 or 0.664 into 10 to the power 10. I told you the unit for the absolute uncertainty has to be same as the Maillard quantity. So if Maillard quantity is 6.87 into 10 to the power 10, it will be 0.667. So the raw answer that I'm getting, raw answer is 6.87 into 10 to the power 10 plus minus 0.664 into 10 to the power 10 pascals. Now the thing is, we have some rules for the uncertainty and the quantity. Who can tell me the first rule about the uncertainty? How many significant figures should we have in the uncertainty?
So 1.
Nobody remembers? Okay, here I'm telling you again. There must be only one significant figure in absolute uncertainty. So there has to be only one significant figure. That means the uncertainty is 0.7 into 10 to the power 10 Pascal. So this will control how many significant figures should there be in the quantity. So what number should come over here? So we have only one significant figure here. What is the decimal position of that one significant figure? It is at one decimal place. What number do we have here at one decimal place?
8.
So this is the cutoff point. This is the cutoff point. This is the point where we should round off the quantity. So if we round it off at 6.8, what is the next number? Is that number more than 5 or less than 5? That number is more than 5. So that
Six.
means it should be 6.9 into 10 to the power 10 plus minus 0.7 into 10 to the power 10 pascals. Does this make sense?
Yes.
So this will be the final answer. Now, what is the second method? Step 1. Calculate E. Very much like you already did. In the previous one, the step 1 was same. So you calculate E and just let it be like this. Now, step 2, calculate percentage uncertainties of data. And do not think it is a choice. Some of you might think that, okay, we understood the first method, we don't need to do the second method. Sometimes what happens is examiner gives you the percentage uncertainties and you are like forced to solve the question with percentage method. So this won't be your choice, what method you want to choose. Examiner will choose it for you. So do not think that if you understand one method, you don't need to pay attention now. So what is the second step? You need to find individual percentage uncertainties. So what will be the percentage uncertainty for the first one? It will be 0.1 divided by 12.5 into 100. So is it 0.8?
Yes.
The second one is 0.01 divided by 1.45.
.68.
0.68.
That's it.
Good. 0.02 divided by 0.55.
3.6.
3.6. And for X,
0.9.
0.9. Now,
9.
listen. These are the percentage uncertainties of F, L, D, X. If we add them, that will be percentage uncertainty of E. But there is a simple catch over here, that you have to remember that D was squared. So you are supposed to add its percentage uncertainty twice. So in the next step, what you do is calculate the percentage uncertainties of data. Now, step 3. Calculate percentage uncertainty of E. So percentage uncertainty of E equals to 0.80 plus 0.68 plus 3.6, and this was multiplied by 2. Why I am multiplying by 2? Because there is a square on D, plus 0.9. Let me check if I got the values right. 0.8, 0.68, 3.6, and 0.9. So what will be the sum of these numbers?
9.58.
Are you sure? Zero point 0.9, 0.8, 1.7,
Yes, sir.
2.38. Yes, 9.58.
Yes, sir.
So we have an uncertainty of 9.58 in the value that we calculated. This is the value that we calculated. So step 4, calculate absolute uncertainty of E. Actually, you have to calculate 9.58% of 6.87, and you can just ignore the 10 to the power 10. That would come with the answer. Just find 9.58% of 0.68. Sorry, 0.68, 6.87. My bad. Just find 9.58% of 6.87.
Six point six into 10 power 9.
It will be 0.66, I guess. Why are you people are so slow with calculators? Like, can't you find just 9.58% of 6.87?
Sir, 0.65.
Is it 0.6 or that there is a number next to 0.6?
There's a number next to 0.6. It's 5.
So if there is a number 5 after 6, you cannot just say it is 0.6. It has to be 0.7.
Yes, sir.
Rounding off requires some. So we have to find 9.58% of 6.87. So you have 0.658. So when you write it in one significant figure, it has to become 0.7. So there we go. We have the final answer as 6.8, which should be now, because the uncertainty is in one decimal place. So we have to round off the answer in one decimal place. 6.9 into 10 to the power 10 plus minus 0.7 into 10 to the power 10 Pascal. This is the final answer. So in percentage uncertainties, we simply add the uncertainties. Okay. Here we go. I am sending you some questions. You can solve them right away and share the answers with me. And I will be solving them on board in a short while. Okay, you can give this question a try.